Well, okay, and we're back. Tonight, we're going to talk about continuous random variables. Now, in introductory statistics and probability, a continuous random variable means normal curve, at least most of the time, okay? And basically, you're looking for a key phrase in the stem of the problem. You're looking to read the time, speed, distance, height, weight, things you measure, right? Those are continuous rather than things you count, which are discrete. You're looking for the phrase, this thing that we measure is normally distributed with a mean of and a standard deviation of. As soon as you see those words, boom, boom, you roll up your sleeves and get to work. Because you can get busy with this stuff. You know it. Table A, normal CDF, bring it on, okay? The next problem we're going to do today is kind of an interesting one. And it goes a little something like this. The average NFL game time is normally distributed. Ding, ding. Okay, so for the NFL, we're normally distributed with a mu for football of 190 minutes and a standard deviation for football of 15. So these are the length of the NFL games. Baseball, on the other hand, is also normally distributed game times with a mean sub B of 175 with a standard deviation for a baseball game of 12. Now, what does that mean? That's just the average length. Some baseball games are really long. Some, when Greg Maddux used to pitch, were really short. Okay? And so what we're interested in here is comparing the two. Now, you might say, well, most of the time football games are going to be longer. And you'd be correct. But we can actually do better than most of the time. We can be specific. And we're going to use table A, we're going to use normal CDF, and we're going to use a little bit of what we learned about combining random variables. Let's see how this works. Okay? All right. Let's let D, the difference, be football minus baseball. F minus B. So F is football and B is baseball. Let's let their difference be F minus B. Can we do the mean difference of the two games? If you said 15, you'd be correct. So the mean of the difference is going to be the mean of F minus the mean of B. Exactly what you think it would be, right? Okay, 15 minutes. How about the standard deviation? Do you remember what we did with our discrete random variables? We do the same thing here. And if you're thinking Pythagorean theorem, you're on the right track. Here we go. Square root of 15 squared plus 12 squared. All right? And so that's going to give us 19.209. Okay, minutes. Now, if the standard deviation is bigger than the difference, what does that tell you? These games are all over the map, aren't they? Yeah, but they are normally distributed. So, interpret. What does that mean? Talk to me. On average, we write this down here. On average, the football game is longer than the baseball game by 15 minutes, and it varies by 19.209. So on average, F and B differ from 15 by 19.209 minutes. Okay? So that means you got a range, right? You go from like -4 all the way up to 34. Is that a little confidence interval? Am I teasing you? Yes. Next chapter. Okay, so let's talk a little bit about what this means. On average, football and baseball differ from 15 minutes by 19.209 minutes. Perfect. The real question of the day, find the probability that the baseball game outlasted the football game for a randomly selected day. So in other words, you pick a day, pick one game, pick another game, or not really a day, but pick one game and another game. Pick one baseball, one football. What's the probability that the baseball will last longer? Should be low, but it's not zero, is it? Right? It's not zero. So how would we phrase that in terms of D? If D is F minus B, and I want B to be more than F, isn't this the same thing as saying the probability that D is less than zero? Oh. This sounds like a normal CDF problem, doesn't it? With a mean of 15 and a standard deviation of 19.209. Yeah. Find the probability D is less than zero. What's that look like? How about a normal curve? And now this is the same problem you've been doing. There's D. What's my mean? Z-score of 0, 15. Where is 0? Well, what did you do when you first learned this? Did you calculate the Z-score? You did. So what was Z? Do you remember? It was data point minus the mean divided by the standard deviation. The Z-score here of negative 0.78. Where is that? Well, let's see. I know that 3 on either side, 99.7% of my data. Here's negative 0.78. That corresponds with a raw score of 0 there. I want everything below here. Oh my gosh. This is the same stuff we've been doing. You see, and that's why this is beautiful. Whenever you see like continuous random variables, man, you gotta be licking your chops to do these problems because you know how to do this. Normal CDF, table A, whatever, go for it. And when you do that, right? When you do that, we're gonna get 0.211 or 2177. Shall we try it? Let's see. Second, VARS, normal CDF. What's my lower? Well, let's make my lower, I don't know, negative 200. My upper is 0. My mean is 15. And my standard deviation is 19.209. Okay? That's how that's going to work. Okay? All right, hopefully you can see that. Now, why negative 200? I don't know. That's like if a baseball game or if a baseball game was 200 minutes longer than a football game, right? That's rarely going to happen. And then when you press paste, you paste that in, I get 2177. And that's what this is, okay? Now, as you recall, we have to interpret this answer. So here it is. There is a 21.77% chance that whatever gains you chose, right? You chose 2 gains at random variable, that the baseball game that you chose lasted longer than the football game. We don't care how much longer. We just wanted it to last longer. That's why our D was negative. there is a 21.7% chance that the baseball game lasted longer than football game, right? Because that's what the D is, F minus B. And as long as B is greater than F, that means D is less than 0. Well, can you put that together? I can hear those synapses reacting in your pea brains. As long as B is greater than F, D is less than 0. And this, my friends, is how you combine continuous random variables and use your work with the normal curve. Have a great evening.